Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 8, Adding and Subtracting Polynomials. So the classwork exercise here, exercise means do it on your own. So pause the video, see if you can do this, and then come back and check. Okay, so here we go. How many quarters, nickels, and pennies are needed to make $1.13? Okay, well, there's all kinds of different choices. You could say 113 pennies, or a nickel, and 8 pennies, and 4 quarters, or any combination. There's 20 nickels and $1, so you could say 20 nickels and 13 pennies. So there's all kinds of different answers, but if I were to use least number, I know there's 4 quarters and $1. So I would say 4 quarters would make the dollar, and 2 nickels would make 10 cents. So I'd say 2 nickels. So now I'm $1.10, and 3 pennies would give me $1.13. So we're leading up to something here. Filling in the blanks now. What is 8,943 if we spread it out like this? Well, the thousands place is 8, so that would be 8 times 1,000, which is 8,000, plus 9 times 100, which is 900, plus 4 times 10, which is 40, plus 3 times 1, which is 3. So it would be 8,000 plus 900 plus 40 plus 3, which is 8,943. And 1,000 is 10 cubed, so that 8 would just be 8 times 10 cubed, 9 times 10 squared, 4 times 10, and 3 times 1. Okay? And we're going to do it again. So now it's 8,943 equals something times 20 to the third power. Well, what is 20 to the third power? 20 times 20 is 400. 400 times 20 is 8,000. So it'd be 1 times 8,000. 20 squared is 400. So it would be 2 of them, which would give me 800, right? So 20 squared is 400. Think of it this way. That's 400. 2 times 400 is 800, but we have 900. So we're just finding the most we can find with this. So it's 2. And we still have 100 left over, which is 5 times 20. Okay, but then we have 40, which is 2 more 20s. So that'd be 5 plus 7, 5 plus 2 20s, which is 7 20s. And then finally 3 1s. Okay, so we took 10 squared and 10 cubed and 10, and now we have 20 cubed and 20 squared and 20 to the first. So now we're just practicing because we're leading up to polynomials. So if I now try to fill in the blanks of this, 5 squared is 25. And there are 4 25s in 100. So that would be 4 times 5 squared would give me the 100. 5 times 2 is 10. That's the tens place. And then 3 times 1 is 3. So 113 is 4 times 5 squared plus 2 times 5 plus 3 times 1. Okay? So hopefully you got those answers in doing this. And let's move on to the next portion. Exercise 2. Now let's be as general as possible by not identifying which base we are in. Just call the base x. Consider the expression 1 times x cubed plus 2 times x squared plus 7 times x plus 3 times 1, or equivalently that'd be x cubed plus 2x squared plus 7x plus 3. What is the value if the expression of this expression if x equals 10? So what we're doing really is what's up here. And our x is our base. So here x would have been 10, here x would have been 20 to make this a true statement. So we're leading up to polynomial expressions. So if I wanted x to be 10, then I would just substitute 10 in for all the x's here. So it would be 10 cubed plus 2 times 10 squared plus 7 times 10 plus 3. Well, 10 cubed is 1,000 plus 10 squared is 100 times 2 is 200 plus 7 times 10 is 70 plus 3. Well, that's going to equal that's 70. It's 1273. 1,273. And now what would be that value if x was 20? Well, the easiest way is just multiply by 2, because if x is 10 and then we're doubling it to 20, then would we just double this? You need to be careful and not do that because of our constant. So I'm just going to substitute it in again. So I'm going to take 20 cubed, and besides that, when you cube something, it's not just doubling. So 20 cubed plus 2 times 20 squared plus 7 times 20 plus 3. So 20 cubed is 20 times 20 is 400 times 20 is 8,000 plus 20 squared is 400 times 2 is 800 plus 7 times 20 is 140 plus 3. And that's going to equal 8,800 plus the 100 is 943. So as you can see, when the base doubled, you didn't just double this number and say it was 2,546. Okay, the answer is 8,943. Exercise 3. When writing numbers in base 10, we only allow coefficients of 0 through 9. Why is that? Okay, and the reason is, once you get 10 of a given unit, you also have one of the unit to the left of that. Okay, so if you add a number, if the coefficient's greater than 9 or 10, then it's actually adding to the coefficient in front. So if I go back and I explain that here, if I had this as 11 times 100, 11 times 100 would be 1,100, which would be 1 times 1,000 plus 1 times 100. So I'm adding to this one, and that's what they're explaining there. So what is the value of 22x plus 3 when x equals 5? Well, then you would say 22, substitute in the 5 for x, plus 3. 5 times 2 is 10, 5 times 2 is 10, plus that 1 is 11, plus 3, and it's 113. How much money is 22 nickels and 3 pennies? Well, 22 nickels and 3 pennies is $1.13. So that's basically what we're doing here. 22 nickels plus 3 cents. Part C says, what number is represented by 4x squared plus 17x plus 2 if x equals 10? So we substitute in 10. Didn't I change my color? Yes, I did. Green, 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 green. 4 times 10 squared plus 7 times 10 plus 2. 10 squared is 100, times 4 is 400. 7 times 10 is 70, and plus 2. So it would be 472. Oh, it's 17. 17, so that's 170. So that moves that to 572. So I just made a mistake there, and in making that mistake, I'm actually avoiding what they're trying to explain from A. What happens if your coefficient is greater than 9? And it adds to the place in front, to the left. Okay, and that happened right here. Our coefficient of x was 17, and that added to our hundreds position because it's more than 10. D says what number is represented by 4x squared plus 17x plus 2 if x equals negative 2 or if x equals 2/3. We have to do this one twice. So we take 4 times negative 2 squared plus 17 times negative 2 plus 2. Well, negative 2 squared, I'm just going to show all my work here because you have to be careful with negatives. Negative 2 squared is positive 4. Plus, positive times a negative is negative, so that's going to be minus. And 17 times 2 is 34, plus 2. So that's 16 minus 34 plus 2. And PEMDAS says that when we're down to addition and subtraction, we work left to right. So 16 minus 34 is 18 negative plus 2, which is negative 16. Now I'm going to substitute in my 2/3. So it's 4 parentheses 2/3 squared plus 17 times 2/3 plus 2. Okay, so that'd be 4 times 4/9 plus 17 times 2 is 34 over 3 plus 2. Okay, and in simplifying that, I get 16 over 9 plus 34 over 3 plus 2. All right. If I want this all in common denominators, it'd be 16 over 9 plus, I needed to multiply the top and bottom here by 3. So it's 3 over 3 here. And that is going to give me 102 over 9 plus, and if I want this to be multiplied by 9, it would be 18 divided by 9 is 2. So that's going to be 16 plus 102 and 18. So 102 plus 18 is 120 plus 16 is 136 ninths. Okay. And E. What number is represented by negative 3x squared plus square root of 2x plus 1/2 when x equals the square root of 2? So let me just move this out of the way now. And I'm going to substitute in the square root of 2. So it will be negative 3 square root of 2 squared plus the square root of 2 times x, which is the square root of 2, plus 1/2. So the square root of 2 squared is simply 2. So negative 3 times 2 is negative 6. Plus the square root of 2 times the square root of 2 is 2. Plus 1/2. Negative 6 plus 2 is negative 4. Plus 1/2. 1/2 is negative 3 and 1/2. Okay, so now the discussion says a polynomial expression is either 1, a numerical expression, or a variable symbol, or the result of placing two previously generated polynomial expressions into the blanks of the addition operation, parentheses, something plus something, or the multiplication operation, parentheses, something times something. Exercise 4. Find each sum or difference by combining the parts that are alike. So it's 4 100s plus 2 100s. So I did the hundreds here. And then it's tens. So there's 1 10 and 3 tens. So tens, actually this is tens. So I'm going to color code this. So that's 4 100s and 2 hundreds. 1 10 here, and the other one has 3 tens. And this has 7 ones, and this one has 1 ones. And then I combine like terms. 4 plus 2, 6. 1 plus 3, 4. And 7 plus 1 is 8. So 417 plus 231 is 648. Okay, pretty basic stuff, right? But the reason they're showing this is because we're now leading up to this and we're doing the same thing. So this is a polynomial and this is a polynomial and they're being added. So we're going to do exactly what we did here and we're going to add like terms. So it's going to be 4x squared plus 2x squared plus, and then my x and 3x plus my 7 and my 1. So we combine like terms here as well. So 4x squared plus 2x squared is 6x squared. X plus 3x is 4x, and 7 plus 1 is 8. So my answer is 6x squared plus 4x plus 8. Okay, so now we're going to do that with part C, but we need to be careful here. This is a minus. So there's a couple of ways we can do this. I can just be careful and subtract each term, okay? Or I can make that a plus and change all the signs inside of here. I will do it both ways because it's important that you understand that that's what's happening. All right, so I'm going to start with my 3x cubed. And I'm subtracting x cubed. Okay, plus, and I'm taking a negative x squared, and I'm subtracting a 5x squared. And I'm just putting plus signs in between here to separate. 8 minus a negative, or there is no x, be careful there too. There's a cubed, a third degree polynomial with a power of 3, a power of 2, and then it skips a power of 1 and goes to the constant. This one has a power of 3, a power of 2, a power of 1, and a constant. So when there is no power of 1, I have to put one there, and that would be 0x minus 4x. Since there's a 4x here, I didn't underline these. So maybe that makes it clearer. 3x cubed, x cubed. Negative x squared, 5x squared. No linear term, a linear term. And then finally, 8 and 7. So that would be plus 8 minus a negative 7. Okay? So when I do this, 3x cubed minus x cubed is 2x cubed. Plus negative x squared minus 5x squared is negative 7x squared. I don't like a plus or minus, so I just write minus 7x squared. And then 0x minus 4x is negative 4x, so minus 4x. And then 8 minus a negative 7 is plus 7, which is 15. So my answer is 2x cubed minus, oh, that's not a 6, that's a 5. I thought that was a 6, it's a 5. Negative 1 minus 5 is negative 6x squared. And then negative x squared minus 5x squared is negative 6x squared. And then 0 minus 4, negative 4x plus 15. There, okay. Now here's another way we can do this. So I'm going to erase this, and I'm going to do it again, and we'll see if we get the same answer. So I'm going to leave my answer there. But this time I'm going to rewrite the whole thing first, and I'm going to say 3x cubed minus x squared. And I'm going to put plus 0x in there, plus 8. So I'm not skipping it. And then I'm going to say plus, and I'm going to change all of the signs in here because I changed that to a plus. So it's negative x cubed minus 5x squared minus 4x plus 7. So you can do that as well. You can change this to a plus if you change all these signs here. So it was positive, 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 negative, 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 positive. And then 3x cubed minus plus a negative 3, or x cubed is 2x cubed. a negative x squared plus a negative 5x squared is negative 6x squared. As 0x plus a negative 4x is negative 4x. And then finally, 8 plus 7 is 15. So I got the same answer, 2x cubed minus 6x squared minus 4x plus 15. So these are equivalent, but they're done two different ways. I would prefer changing it to a plus and making all these opposite. So, and putting in this missing term. Okay? So now looking at this one, we have to distribute. We have a cube, we have a first degree, we skip the second. We have a cube, we have a constant. So we don't have to, there's no second degree in either one, so I don't need to put that in, but I could. And then we have a linear term, no linear term, and a constant and no constant. So first thing I'm going to do is distribute. 3x cubed plus 8 times 3, 24x. Okay, and then it's going to be minus, and then 2 times x cubed is 2x cubed, and keep this in parentheses. Actually, no, I don't want parentheses if I'm distributing, I'm getting rid of them. So a negative times a positive is negative, 2 times x cubed is 2x cubed, and a negative times a positive is negative, 2 times 12 is 24. So now it's 3x cubed plus 24x minus 2x cubed minus 24. So my like terms are just the cubes. 3x cubed minus 2x cubed is simply x cubed. Then we have a 24x but no other x's, so it's plus 24x. And then we have minus 24. So the answer is x cubed plus 24x minus 24. Okay? And they're just throwing different examples at us that are in different forms. So if I take a negative t squared plus a t squared, they cancel and go away. Bye-bye. If I take a negative t and add 9t to it, I get 8t. If I take a 5 and add nothing to it, I just have 5. So this is simply 8t plus 5. Now another way, if that was confusing to you, is to rewrite it out. So I would take this and rewrite it in standard form. So that would equal negative t squared minus t plus 5. Okay, that's just this term rearranged. And then I'm going to say plus, and then put this in order. So t squared comes first, plus 9t. And if you want to put a constant in, because there's one over here, then I put 0. Then they're in order, and then I take negative t plus t squared. Negative t squared plus t squared is nothing. It goes away. And then negative t plus 9t is 8t. And finally, 5 plus 0 is 5. Okay, so f, I have a distribution here I'm going to focus on first. So I'm just going to rewrite this. 3p plus 1 plus 6 times p is 6p. And actually I don't need the parentheses here. So let's just leave it 3p plus 1. And then 6 times p is 6p. And positive times a negative is negative. 6 times 8 is 48. And I'm going to say plus, and then I'm going to distribute this. Or I can just distribute the minus throughout. So I can do it that way as well. A negative times a positive is negative p. A negative times a positive is negative 2. And then I combine like terms. 3p plus 6p minus p. 3 plus 6 is 9, minus 1 is 8p. 1 Minus 48 is negative 47. Minus 2 is negative 49. 8p minus 49. I didn't show my arrow for my second distribution. Okay, and so I click on that and it stays green. I love that. There we go. Okay, so it's 8p minus 49. Okay, that is the end of lesson 8. Review the lesson summary and go to your problem set.